Hello everyone, in this video we will be discussing volumes of solids of revolution. So there are three types of volumes of solids of revolution. These are the circular disc method, the cylindrical shell method, and the ring method or washer method. So in this video we will be discussing each of these method for the volumes of solids of revolution. So to better understand this one, supposing we have our axis of rotation for this one. We have an axis of rotation, an x-axis, and supposing we have a strip around touching our axis of rotation. Supposing this is our strip, and we are rotating along this axis. So meaning to say, if we rotate this strip along x-axis, we can have a representation of this one. Meaning to say the strip will be extended around this area. And in 3D, this will be represented by this one. So that's why this is called a circular disc method, because it looks like a circular disc, just like this one. For the cylindrical shell method, supposing we have our axis of rotation around this area, for the cylindrical shell, the axis or the strip is parallel to the axis of rotation. So meaning to say, if this is the axis of our rotation, we have our strip here. So for example, this is our strip. And if we rotate our strip around this axis, meaning to say, we also have strip here below. And then that will form a cylindrical shell. If you form that one in 3D, it will form something like cylinder. And pardon my drawing. So it will form a cylinder just like this one. And then this is our strip that we have, this one, as well as this one. So these are the strips that we have, represented by this one, and as well as here. For the ring method or washer method, it just basically, I think, the combination of the disc method and the shell method. So supposing we have our axis of rotation around x-axis, and if we have our it is perpendicular but not touching our our angle or rotational axis. So this is our strip. Now if we rotate this one along x-axis, we'll have another strip down here. So that being said, it will if you redraw this one using 3D, you will form a circular ring. For example, we will have like this. It's just like the same with circular disc, that it has a hole in the middle, and it's also just like the cylindrical shell, but it's not elongated. That's why it's just it's just a combination of the two methods that we have. So these are the representation of our methods that we will be using later on. So for the equation of the volumes of each of the method here, we'll start with circular disc. So the volume of the equation of the volume for the circular disc, if we have our strip in if we have our vertical strip, we will have our equation as equivalent to pi from a to b, that is our limit, and then we have our y squared dx. Now, if we have our horizontal strip, our volume will also be changed. Basically, its variables will just be interchanged. So we still have phi from a to b. Then we have the x squared dy if our strip is in horizontal. For the equation of the volume of our cylindrical shell, if our strip is in vertical, we have v is equivalent to 2 pi integral of a to b. We have our xy dx if our strip is in vertical. But if our strip is in horizontal strip, so we have our volume as equivalent to 2 pi from a to b xy dy. So basically, the changes of our with respect to x or with respect to y is the only thing that will change. For the volumes or for the equation of the volumes of the ring method or the washer method, we have V is equivalent to pi from A to B. Then outer, we have the outer radius squared minus the inner radius squared. Then we have our dx. So meaning to say, um, this radius here is our outer or our y2, and the radius inside our inner loop or inner hole is our y1. So that is how we solve for the washer method or the ring method. For example, we have here the problem, find the volume of the solid of revolution generated by rotating the curve y is equal to x cubed between x is equal to 0, y is equal to 0, and y is equal to 4 about the y-axis. By about the y-axis, we mean here that it is revolving or our strip is rotating around the y-axis. So in solving this one, before we will know what kind of method we will be using, we need to sketch our graph first. So meaning to say we need to substitute some values to our function, and then we'll know later on what is the resulting method that we will be using. So first, let's try to substitute some values to our function, which is y is equal to x cubed. So again, we have this boundaries here, y is equal to x cubed, x is equal to 0, y is equal to 0, and it is rotating about the y-axis. So that being said, we need to substitute some values to our x and y's for our function. So our function here is y is equal to x cubed. Now, if we substitute some values to our x and our y, as we know, our y is bounded by 0 and 4. So if we substitute 0 to our x from here, meaning to say our y is also 0. If we substitute 1, our y is also 1. If we substitute 4 here, as we know, the boundary of our graph is equal to 4. So we already have the 0, which is this one. We also already have the x is equal to 0, which is this one. So if we substitute 4 to our function, meaning to say, if we'll replace this one, 4 is equal to x cubed, the value of our x is equivalent to cube root of 4, as we know from this equation. Now, graphing this one to our Cartesian plane, we have, let's have here our Cartesian plane. Let's say this is our x and this is our Cartesian plane. So let's say this is 0, 1, and cube root of 4, that is approximately equivalent to 1.59. Approximately equivalent to 1.59. 0.59 or closely to 1.6. So our y has values from 0, 1, 2, 3, and 4. So if we graph this one, 0, 0 is around this point. We have 1, 1 around here. We have 1.6 around here to our 4, which is here. So if we try to connect our points here, we'll have this curve. Supposing this is a perfect curve. So we have like this. And then we know that we have our boundaries, which is x is equal to 0, meaning to say we are bounded by this one. This is our x is equal to 0, right? Now we also have the boundary y is equal to 0. So meaning to say our plane is bounded by here. And we also have y is equal to 4. So as you can see now, our solid of revolution is now bounded or is now closed. So meaning to say, if we use, since it is rotating around y-axis, since it said that it is rotating around y-axis, we can use two methods here. The first method is the circular disk method, or this one. I'm sorry. This one. We can use this one since it is rotating around y-axis. It is said to be rotating around y-axis. So meaning to say we can have our strip, we can have horizontal strip. So as you can see, our strip is touching the one side of our rotational axis. So meaning to say if we rotate this strip here to the around y-axis, we'll have another curve here, then we'll have the extended strip around this area as well. So meaning to say, we can use the circular disk for this equation. So if we use a circular disk in our equation, we will be using this equation. Since our change or our strip has a change with respect to y, since this is horizontal. So meaning to say if our strip has changed in y, our limits will also be with respect to y. So as you can see from our substitution earlier, we have our lower limit is equivalent to 0 and our upper limit is equivalent to 4. So we have our volume is equivalent to pi time integral of 0 to 4. Then we have our x squared dy. But in our case, our function is y is equal to x cubed. So we need to find a way that will extract the value for our x squared here in our function. So meaning to say, if we multiply both sides by 1/3, we'll have y cube root of y, right, is equal to x. So meaning to say, we can already substitute this one to our equation, which is x squared dy. We just have to square this one. So meaning to say, cube root of y squared, then we have our dy. So afterwards, normalizing our equation, we have pi from 0 to 4, cube root multiplied by 2, that is y raised to 2/3 dy, right? Then afterwards, we can already integrate this one. So we have integral of y raised to 2/3, that is equivalent to y raised to 5/3 over y raised to 5/3. Then we have our limits from 0 to 4. So substituting our limits to our equation, we now have pi is equivalent to 4 raised to 5/3 all over 5/3 minus 0 raised to 5/3, that is still 0, right? All over 5/3. So meaning to say we can just cancel this one since this is equivalent to 0. So if you calculate this one, we'll have the result of 18.99 or closely approximately equal to 19 cubic units. Since we are talking about volume, meaning to say our unit will be in cubic units. So this is now the final answer of our equation using our circular disc method. Now again, as I've told you earlier, we can also use cylindrical shell method in this example. So we'll solve that one using cylindrical shell. Solving this problem using a different method, but this should come up with the same final answer, which is 19 cubic units or 18.99 cubic units. We just have to modify our equations, the equation that we will be using. So since for this example we use the equation for the circular disc method, now we will be solving this problem using cylindrical shell method, meaning to say we'll be using this equation for cylindrical shell. But the graph is the same. It's just that the strip will be different because as we know, the strip for cylindrical shell is parallel to the axis of rotation. So in this case, our axis of rotation is y-axis, meaning to say our strip should be in vertical strip. So let's just erase this one, but you have to remember that the final answer is 19 cubic units. Now we should come up with the same answer later on. So having the same substitution or having the same value for our function, we'll just regraph this one. So we have our y-axis, we have our x-axis. Again, we have 1 and 2. We have 1, 2, 3, and 4. We have 0, 0. This is in this point. 1, 1 is around here. And 1.6 and 1 and 4 is also around here. Then we have the same boundaries. We have x is equal to 0, which is this line. We also have y is equal to 0, which is this line. We also have y is equal to 4. And then we have this curve, which is equivalent to y is equal to x cubed. And then our axis of rotation is about the y-axis. So meaning to say, if we use cylindrical shell method, we need to have our strip altered as well. Since for the cylindrical shell, our strip should be parallel with the axis of our rotation. So supposing this is our strip, meaning to say this is in the change of x because this is in vertical strip. Now again, if we rotate our area around the y-axis, we now have this form or the solid. We now form this kind of solid. Now since our strip is in vertical, meaning to say since we already rotated that one, we also have a strip around this area. And that gives us the the form of cylindrical shell, just like this one. So that being said, we can now already solve this one. However, as we know, our limits will also be changed since this is change of x. So the limits that we will be using is also the limits with respect to our x, which is from 0 to cube root of 4. So we now have the equation of our the equation of our problem as equivalent to v is equal to 2 pi, as you can see from here. And then we have our limits from 0 to cube root of 4. And then we have our x. And for our y, that should be since this involves two curves, we have y is equal to 4, and this curve is y is equal to x cubed. As from the knowledge that we have from the finding the areas of finding the areas between curves, we know that we need to include the y upper minus y lower. So in this case, our y upper is equivalent to 4 and our y lower is equivalent to x cubed, as our strip touches the upper part of our strip touches this line, meaning to say this is our y upper, and the lower part of our strip touches this curve, so meaning to say our y lower is equivalent to x cubed. So we have 4 minus x cubed, and then we have the change of x. So simplifying our equation, we have 2 pi from 0 to cube root of 4. We have the 4x minus x to the fourth dx. Then afterwards, we can already integrate this separately. So we have 2 pi, and then the integral of our function, which is 4x squared all over 2 minus x to the fifth all over 5. Then we have from 0 to cube root of 4. But as we know, 4 divided by 2, that is 2. So we can just replace this one by 2x squared. Then substituting our limits, we have 2 pi times 2 times cube root of 4 squared minus cube root of 4 to the fifth all over 5 minus 0, since if you substitute our lower limit to our equations, it will come up to 0, so just simply put 0 there. So if you calculate this one, this will also result to 18.99, which is approximately equal to 19 cubic units. So basically, if you will be using two different methods in solving one problem, you need to make sure that you come up with the same result, even though you use different equations. So that's it for the cylindrical shell. Now let's move on to another example, which is for the example of our the ring method or the washer method. So another example we have here, find the volume of the solid of revolution or solid generated by revolving the region between y is equal to x squared and y is equal to 2x about the x-axis. So basically in this kind of problem, since we are already given two functions or two equations for our y, so uh, the the thing that we need to do here is equate our two equations so that we can find the limits of our we can find the limits of our volumes or for our equation. So if you say y is equal to y, you know that the other equation of y is x squared and the other is 2x, meaning to say x squared is equal to 2x. Now if you equate this one to 0, x squared minus 2x is equal to 0, you'll get two values of our x, which is x is equal to 2 and x is equal to 0. So meaning to say this is now the limits that we will be expecting later on if we graph or if we substitute values to our equations. So now meaning to say we have again x is equal to 2 and x is equal to 0. So if you substitute some values to our y is equal to x squared, let's start with y is equal to x squared. Substituting values to the equation, we know that the limits of our x is from 0 to 2 only. So meaning to say if x is 0, our y is 0. If our x is equal to 1, our y is also equal to 1. And if our x is equal to 2, our y is equivalent to 4. So we can already stop if we have already substituted the limits that we need to have. So we have from 0 to 2. Now for the other equation, we have y is equal to 2x. So again, substituting some values so that we can graph it later. We have if x is equal to 0, we have our y as 0. If x is equal to 1, we have our y as 2. If x is equal to 2, our y is 4. Now, we can already graph this one in our Cartesian plane. So, for example, we have this one as our Cartesian plane. We have 1, 2, 1, 2, 3, 4. So first, let's graph this equation. We have 0, 0. We have 1, 1. We have 2 and 4. So it's around here. So if you plot this one, you have this. Now for the other equation, we have 0, 0. Same, it's here. 1 and 2. So it's around here. Then we have 2 and 4. That's the same around here. Now, if you plot this one or if you connect the points, you'll have this curve. So as we know, again, this curve is our y is equal to x squared. And for this curve, we have this is y is equal to 2x. Now again, from our problem, it is said that our solid will be revolving around x-axis. So meaning to say, if you revolve this one, if you revolve this solid that it has generated, meaning to say, you'll have another one of this in this one. So meaning to say, if you put strip around this one, meaning to say it also has a strip around this solid here. So as you can see, if you have to imagine this one, this will form a circular ring or a washer method. So using washer method, we have V volume is equivalent to pi integral of a to b, the radius of the outer curve minus the radius of the inner curve. So as we know, again, this is our outer curve, and this is our inner curve. So again, if you try to create a circular disc. Here we have this form. So now, that being said, our volume is equivalent to pi, and then our limits, since our strip is vertical, meaning to say our limit is with respect to x. So meaning to say that is from 0 to 2. And then, as we know, what is our upper or what is our outer equation? That is equivalent to 2x. So meaning to say we have 2x squared minus our inner, which is x squared, and then we have the dx. So simplifying our equation, we have pi is equal integral of 0 to 2, that is 2x squared, that is 4x squared, minus x squared, that is x to the fourth, and multiply by dx. So we have integrating our function. So we have pi, then 4x cubed over 3 minus x to the fifth over 5. That is from 0 to 2. So substituting our limits, we have pi 4 times 2 cubed all over 3 minus 2 to the fifth over 5 minus our 0 for the lower limit. Now if you calculate this one, this will result to 64 over 15 pi cubic units. So this is now our final answer. So that's it for this video. Thank you so much for listening, and I hope you learned something from this video.